Hello friends, welcome to Enhance Creativity YouTube channel. In this video, we're gonna discuss an important topic for competitive exams, that is calendars. This video includes introduction to calendars, in which we discuss about odd days, a leap year, an ordinary year and a century leap year. In the second part, we learn year codes, month codes and day codes, which are used to solve calendar problems. In the last part, we solve different types of problems related to calendars, which are useful for SSC, banking and others. Let's start the video. At first, a calendar is used to measure the time. This can be done by using the names such as days, weeks, years, date and months. Now, let us learn some important terms related to calendar. And the first one is day. A day is defined as the smallest unit of a calendar. A calendar has 7 different types of days. They are Sunday, Monday, Tuesday, Wednesday, Thursday, Friday and Saturday. Now the second term is week. Week is defined as grouping of 7 days, that is from Sunday to Saturday. Now the next term we use is odd days. Odd days is nothing but the remainder obtained when total number of days is divided by 7. For example, when 23 is divided by 7, we get 2 as remainder. Here 2 represents 2 odd days, which means there are 2 odd days for a total number of 23 days. Based on number of odd days, day codes are given by, if the number of odd days is equal to 0, it represents Sunday. For 1, it is Monday. For 2, Tuesday and so on. Now the next term we use is month. A month is defined as grouping of weeks. There are 12 months in a year. They are January, February, March, April, so on up to December. In order to find number of days in a month, we use a tricky method. That is, hold your fist tightly as shown in the figure. Now, observe the bones at the end of your fingers. The bones are higher than the flesh in between them. These bones denote months with 31 days and the flesh in between them denotes months with 30 days. But in case of February, in an ordinary year there are 28 days. In a leap year there are 29 days. Now let us learn month codes, which are useful for solving calendar problems. For January, the month code is 0. For February, it is 3. For March, it is 3. And so on up to December. These codes can be easily remembered in such a way that the first 3 and the last 3 codes are 033 and 035 and the middle 6 codes are 614 and 625. The next term is year. A year is defined as grouping of 12 months, or the time it takes the earth to complete one revolution around the sun. Earth takes 365 days, 6 hours and 9 minutes to complete one revolution around the sun. The terms that are frequently used in calendars are: first one, ordinary year. A year is said to be an ordinary year if it is not divisible by 4. Examples are 1983, 1989, 1990 and so on. An ordinary year consists of 365 days, that means 52 weeks plus 1 odd day. Now the next term is leap year. A leap year is defined as a year which is divisible by 4 but not 100. Examples are 2004, 2008 and so on. A leap year consists of 366 days, that means 52 weeks plus 2 odd days. Now the next term is century leap year. A century leap year is a year which is exactly divisible by 400. A year is called a century leap year if it ends in 2 zeros, but it is called a century leap year if and only if it is divisible by 400. Examples of century leap year are 1600, 2000 and so on. The year codes to be memorized are: from 1600 to 1699, the year code is 6. From 1700 to 1799, the year code is 4. And from 1800 to 1899, the year code is 2. And from 1900 to 1999, the year code is 0. And the same cycle repeats for every 4 years. Now let us try to solve some questions. The first question is, on which day of the week does 28th August 2009 fall? In order to solve such type of questions, we need to use the codes we have discussed earlier. We get the solution in 5 simple steps. In the first step, we write down the last 2 digits of the year. In the second step, we divide the last 2 digits of the year by 4 and write down the quotient. In the third step, we write down the date. In the fourth step, we write down the month code. In the fifth step, we write down the year code. Now, we write down the last 2 digits of the year, that is 9. In the second step, and the quotient we get when 9 is divided by 4 is 2 and the date is 28. Month code for August is 2. Year code for 2009 is 6. Now we add all the numbers. On adding, we get 47. Now, we divide 47 with 7. When 47 is divided by 7, we get 5 as remainder. From the day codes, 5 represents Friday. Therefore, the answer is Friday. Now, let's try to solve another question. On which day of the week does 29th February 1996 fall? Going to the solution, as same as the previous problem. In the first step, we write down the last 2 digits of the year, that is 96. In the second step, when 96 is divided by 4, we get 24. Therefore, we write down 24. In the third step, we write down the date, that is 29. In the fourth step, we write down the month code. Month code for February is 3. In the fifth step, we write down the year code. Since 1996 fall between 1900 and 1999, the year code is 0. Now we add all the numbers. We get the total sum as 152. Now we divide 152 with 7. When 152 is divided by 7, we get 5 as remainder. Since 1996 is a leap year and the day falls in the month of January and February, we subtract 1 from odd days. That is, when 1 is subtracted from 5, we get 4. 4 represents Thursday from the table. Therefore, the answer is Thursday. Now, the next question is, which year will have the same calendar as that of 2009? And the solution is, since 2009 is an ordinary year, we start writing number of odd days for every year from 2009. We write years until 7 or multiples of 7. Number of odd days for 2009 is 1 and number of odd days for 2010 is 1 and for 2011 1. Since 2012 is a leap year, we get 2 odd days, and for 2013 1 and for 2014 1. Now, when we add all the odd days up to 2014, we get the sum as 7. When 7 is divided by 7, we get 0 days, and the year after 2014 is 2015, which is an ordinary year. Therefore, 2015 will have same calendar as that of 2009. The important note is that if the year after 7 odd days is not an ordinary year, we write up to the next multiple of 7. Let's try to solve another question, that is, which year will have the same calendar as that of 2012? And the solution for the question is, since 2012 is a leap year, it is not necessary to write years and odd days. We can get answer directly by adding 28 to 2012. When 28 is added to 2012, we get 2040. Therefore, the answer is 2040. So, the year 2040 will have the same calendar as that of 2012. Friends, I hope the video is clear. Now, try to solve on which day does your date of birth fall, and comment your date of birth and day in the comment section below. Thank you for watching the video. For more helpful videos, please do like, share and subscribe to my channel Enhance Creativity.